So hey guys, again, this is the continuation of our series of linear regression. We already did a lot of things together. We explained to you what's a linear regression, what's a linear function, cost function, normal equation. We even made some examples with some made-up examples, made-up data sets that we created, thinking about time, company, and increasing salaries. But now we're going to make with a real data set, and we will use this fetch California housing. It's basically a scikit-learn data set, and the scikit-learn has a lot of uh, different data sets that you can try. They call it toy data sets.
But these ones are real values,
Yes,
real life. Let me see. They are, oh my,
they're real world,
real
situations.
real data
Data
sets.
set.
Yeah.
Yes, and to get this data, you can just use this import here. That is the data sets from scikit-learn, and you have to import that in your code. That's why it's here in the first line of code, and you can make it equals to some variable that you created. In our case, we created the data one. And in our case, we decided to use this parameter here, the return x, y, and it basically makes the data variable that we created receive only the values of x and y instead of a lot of noise that we don't want in the code. And we also created another variable called data1 with all the noise because we wanted to check the names of the columns, the features of the axis. Yes, because remember this return x y basically cut all the noise. So x and y numbers is what we have, and we have feature names in the data set. So we had to create this data one in order to check the inputs that we have for the houses. So here they use a lot of different inputs in order to figure out the price of a house, like number of bedrooms, population in the block,
Net income.
Yes, latitude and longitude of the house. And well, our x's and our y's are basically the data 0, the first column, and the second column because we cut it all the noise.
Yeah, but the first column actually is the data is a tuple. So the first part of the tuple are 8 columns with all the values of x.
Yes, we can quickly check here, printing like x0 so that you can see it. And also we can print y0.
It's going to print all the data, no?
Yes.
No. Just the first
row. Just first row, yeah.
X uppercase.
Oh, sorry guys, X uppercase. Yes, that's right. Oh, wait. So the first is a tuple. No, the first is array, sorry. It's a tuple and X is array. In this array, we have all the 8 features. Each one of these guys here is one feature. The first one is the
median
income and house, age, and average of rooms, average of bedrooms, and in the end, in the y0 is the final price for that input. If you change here for 1, you're going to see the second house with all the 8 parameters and the output y is just the same. Okay, so we have the x and the y, and we want to correlate that using linear regression. So we just follow the same steps that we did with our fake made up data set. We create a model. Always this step, guys. Create a model, in this case, linear regression model. And we have to feed the data. In our case, we know that our x is data 0 and our y is data 1, just like we described here. Oh, and it's fun because you can put those together. We could just say fit and put data 0, data 1.
Oh, X and Y.
Yes, or X and Y. And I just made different lines because it's easier to understand like this, because it's a step-by-step thing. And we printed the shape here because this is something important in programming, is that every time that you do an important step, you should check to see if it's correct.
Exactly.
Otherwise, you're going to spend a couple of years to make a simple program. Okay, so just like the other model, feed the data, and then I printed the coefficients here. And see, really easy, guys. Nothing really hard. Scikit-learn makes things really easy with basically 2 lines. You already can figure out the line that best describes the situation. And we can use the number equation. Remember number equation that we just learned, to check if those are really the best parameters possible.
Yeah.
Right, Mauricio?
Right. So here we find the intercept and the coefficients for each input, each data. And then now we will use the normal equation method to find the same. See if
They are the best,
Yeah,
actually.
exactly. So we do the same steps, print the shape just to check if it's all right. Create the x2.
Yeah, guys, because
Y2.
matrix multiplication is some crazy thing. So you have to keep tracking the shape in order to be sure that you're multiplying correct the matrices.
Yeah. And again, we create another vector of ones with the same shape of data 0. That's our x vector. And we print the shape again of each of them. And then we concatenate the x2, that it's our x, with our vector of ones, just to have this, this vector.
Guys, it's just the same explanation from before. And yes, the same algebra, the same calculus.
Yeah, and we make these vectors this transpose. This our x vector to find this here, and then we find this here, the inverse of this one, and when we multiply them, just near this, when you multiply them, we find the best values of data, and here they are. The best coefficients are ta-na-na, and they are
the same.
Exactly the
we
same.
found before, and this is a real data set, guys, not a made up one. So you could say, oh, you just made up the data so that they fit perfectly. No, this is a real data set, and you can check that by yourself, changing the data set using any of the data sets from scikit-learn or your own data set. Numerical equation always are going to tell you the truth.
Yeah, and there is one more way to do it, that is separate train data and test data.
Well, guys, this is important to say that in this way, normally you will not have the same accuracy that we had before. Like in the other 2 examples that we made, we just fit perfectly the line, right?
But in this one, we train the data with some part of the data that we have, the data set that we have, and use another part of the data to make the test.
Yes.
So we are using data that the model doesn't know yet, and this way we can also see if the model is predict correctly. It's predict as a good accuracy as Diego said.
Yes.
And those points, I think that the red one is our hypothesis, is the
Predictions.
as our predictions, and the green ones are our real
Values.
real values. And in some houses, the value were good. The
There
prediction was
are
good.
some outliers, just
This one,
yes, and the other
this
next.
one.
But all the others, you have a very not big mistake.
Good prediction.
Error. Yeah, good predictions.
So I think that's it for this video. And in the next one, we will do another program to just to compare gradient descent and the number equation and better visualize how both of them work.
So bye bye guys, and see you in the next video.
See you.